So what was happening was the bearings were wearing out on these scroll compressors due to an overcharge because that liquid refrigerant was coming back in there, diluting the oil, and the rotor would go into the winding of the compressor, the wires of the winding, and it would short out. Okay? When a technician come up to it to analyze what was going wrong, they would have seen an electrical failure. But the electrical failure was a result of an overcharge. So when you're out here and you hear somebody say it's a scroll compressor, don't worry about it, the charge is not that important, wrong. It is important. Okay? Sounded like a good solution to overcharge problems, but it is not. Okay, one of the other type compressors that we haven't, I don't have one to demonstrate here, I hope we have one in the near future, is a rotary type compressor. Okay, rotary vane. There's two different types of rotary vanes. There's one that has a stationary vane, and then there has the one that has the vane that rotates with the rotor. Basically, they're small compressors. They're usually not large. They do not take an undercharge very well at all. They will fail quickly with an undercharge because that vane has to be lubricated. It's very small clearances within the compressor. Lack of lubrication causes it to fail very quickly. Now, you will see the rotary compressors in domestic refrigerators. That's a real commonplace. Some of the window units, sometimes you'll see them in water coolers, things such as that, but they're usually limited to small applications or small capacities. All right, another one that I don't have here is going to fall back into the industrial commercial, and that's a rotary screw, entirely different than a rotary, entirely different. The rotary screw compressor is like having two screws. One is the drive screw, the other is driven, and it moves the refrigerant like so, like two screws turning. I don't know exactly how to explain that with my hands, but you can think of that way. If you've ever done any drag racing or been around the drag racing circuit, you'll hear of a blower. Well, they work just like a blower. The refrigerant moves on the outside of the housing. Okay, that technology has come a long ways. It used to be limited to very, very large compressors. Now I think they're actually having them somewhere in the neighborhood of 15 horsepower and smaller. Or I know they're larger, but I don't know how much smaller they've been able to make that. It is a very expensive device to build and engineer, and when they do fail, they do have to be serviced after so many hours, but when they do fail, we call them scrambling. Because if you can think of a scrambled egg, that's about what it looks like when they do fail, if you don't service them and have them rebuilt before that point. So it's, like I say, that's more in the industrial, commercial end of it. Okay, well, how long should a compressor last? What's the age of a compressor? What should be the age?
15,
20? That's probably in the average. But the truth is, if everything is working correctly, if you have the proper refrigerant for the proper cooling, if you have the oil in there like it should be, and the oil is being returned as it should be, it should never wear out. The bearings don't wear out if the oil is doing its job. We know that doesn't happen, and usually we blame the compressor for the failure. Very seldom is it truly the compressor that causes the failure. Something else takes it out. And you know, there's a lot of things that can take it out. Probably the number one item is a dirty air filter. If you have a dirty air filter, you're going to get liquid back to the compressor, and when you get liquid back, you're washing the bearings out. Okay. The other, of course, would probably be overcharge. Another would be undercharge. Any of those things can affect it. All right. Let's hit a couple of other subjects while we're going, and then we're going to call it quits on this one. One is compression ratio. You don't hear a lot about compression ratios the way you used to, but it's still there. Now, when I say compression ratio, I'm not talking about the mechanical displacement of the compressor. Not, you know, you hear like automotives, you hear those that's 11 to 1 or 10 to 1, high performance engine, things like that. I'm not talking about that. I'm talking about the ratio of the suction gas to the discharge gas, both measured in absolute pressure. Okay, it's pretty simple. I take the suction pressure, okay, and I add 14.7. Y'all know where that 14.7 comes from?
Atmospheric pressure?
Atmospheric pressure. I divide that into the high side pressure plus 14.7. Okay, ideally, I would get a 3 to 1 ratio. Okay? If I'm getting higher than that, the problem is the compressor's working harder than it should. You know, an ideal situation would be 1 to 1, but if I had 1 to 1, how much gas would I move? None. So I've got to have a ratio difference here. But you will find out that if this suction pressure varies a little bit in comparison to the high pressure, the ratio will go or change more. Okay? So the ratio needs to be kept somewhere in 3 to 1. Well, what would affect that? What if I have a real hard load or real high suction pressure? Okay, believe it or not, that's going to decrease my ratio, but the unit's going to work harder. Okay, if my suction pressure goes down, then my ratio is going to actually go up. I may have said that backwards a while ago. If my suction pressure goes down, my ratio is going to go up. Where the compressor may not be pulling as many amps, but the problem is working harder to do the same amount of work over the long haul. So when you get into compressors, learn a little bit about that. I don't expect you to become an expert overnight, but you'll see as you deal with this that it does affect it quite a bit. Unloaders. One of the beauty of some of the industrial compressors, commercial industrial compressors, is we could actually unload them or match the load that the compressor was doing according to the load of the building or the unit that it was operating. Centrifugal compressors, they had unloaders or vanes that controlled the amount of refrigerant that was going into them. That's the way they were operating. Piston types are reciprocating, will actually unload the valves and let the refrigerant circulate back within the compressor. Only problem about that is you don't always get the cooling properly. Okay, the scroll technology has actually come up with a way that it actually lets the two plates open up. Now when I'm talking about spreading apart or opening up, I'm not talking about very much at all. I'm talking about just a few thousandths. When it does, it lets it unload. They're using the digital technology now to do that. Now some had two-step unloaders, but I understand that the newer way of doing it, or the better way nowadays, is actually through a digital, where a small solenoid just jars it up and down like so. And we're able to match the load and the compressor much closer. Okay, some compressors are going to have sight glasses, oil sight glasses. Now, when checking the oil on a compressor, it should be between 1/3 and 2/3 in normal operation. The level should be somewhere on the sight glass along in that line. Now, if you come up to a system and that sight glass is low, please don't just start adding oil. That oil had to go somewhere. If it didn't leak out of the system, it's caught in the system somewhere. You need to find out where it's at and make sure that you get that problem solved. Refrigeration in particular can have the refrigerant to lodge into the evaporator right before a defrost cycle, because your velocities of your gas have become low, where the TXV is not feeding the refrigerant very much in there, so the oil will actually separate and get lodged into the evaporator. If you add more oil to that compressor and then it goes into a defrost or whatever and brings that oil back, now you got too much oil and you take a chance of a slug of oil coming into the compressor and burning it. Of course, needless to say, if it's not enough oil in it, you need to add oil. But don't do that until you know where that oil went. Okay. Bottom line, they should serve many years if everything in the system's operating properly. I want to switch gears a little bit here from the mechanical end and go to electrical. It's needless to say that the compressor needs the proper voltage going to it. If you have loose connections though, especially on the terminals, you can run the compressor. The loose connection will make heat, it will burn the terminal. Please do not, under any circumstances, try to solder or braze anything to one of these terminals. This is a glass, what do they call that? The terminal piece here.
Insulator?
Insulator.
Mm-hmm.
Okay. If you put heat on here, remember this thing has got pressure in it. If you put heat on here, you're going to bust that. And if you don't get hurt, you're going to have a fire anyway. But another thing is, when operating this, there should be a cover over the top of this. Don't operate one of these without a cover over it. I have literally seen one of these blow out. Not a pretty sight, because you have the oil coming out. The refrigerant will put the fire out, by the way, but the oil will burn. But if you have loose connections, it will burn those terminals. Okay. Compressors can tolerate up to 20% overcurrent for a short period of time. In fact, we're going to get into some accessories, and you actually will measure the current draw to set up what they call it EPR, evaporator pressure regulator. But if you're looking at the current draw and it's exceptionally high, be aware that something's going on in the system. That's not normal. It will be under high load, but only for a short period of time. Check your voltages, check your contacts. In fact, some compressor manufacturers, if you change the compressor, they require you to change the contactor in order to honor the warranty. A bad contactor can cause the compressor to go bad. Okay. I can't really think a whole lot more to talk about, so we're going to sum this one up. I want you to come up and take a look at some of the compressor parts. We have some more out in the shop. We'll just take a look around, and understanding how it's made on the inside helps you to understand how it's supposed to operate on the outside. That makes sense? Okay. All right. That's going to conclude this.